Everybody. Today's lesson is brought to you by the TI Inspire. Even if you don't know math, this will help. Subscribe to my channel and buy a TI Inspire calculator. Huh? No. No, I have not. What was wrong with that? All right, that's where I'm going next. The problem is I don't think anybody's going to subscribe to my videos, besides you guys. I do. No.
You should vlog your daily life as a teacher.
All right. Well, today I wore a flannel shirt. Yeah. All right, I'll tell you what. If I get some subscribers and some things, yeah. But any money that if I happen to make any money, Well, no, I'm not gonna. I'm gonna buy things for the room. Like I want to buy, like instead of having that, I want to have a nice. No. I want to have a nice flat screen TV, right? And I want to. No. Instead of having that right there, I want to have a flat screen TV with like a rotating thing with what's going on and like. I got another 15 years, 14 years. Yeah. Why? The TV. Oh, it is? 41. Yeah. What?
That's so rude.
T, really? Wait, hang on a minute. Time out. Oh, hang on. Show of hands. All right? Except for you. Anybody else think I was 50? Darn. That's not hot. That's good. I like you guys. Thank you.
You look so sad now.
I know. You made me so. Yeah, it did. It was bullying. It was bullying. Yeah. Yeah, that's right. Let's beat them up after class. $50. All right, here we go. Guys, this unit is gonna not it's a short unit. We'll be done with it by Thanksgiving, so we got like literally 2 weeks. Okay. And 90% of what we're going to do is calculator work, okay? And we can do with the calculator, and we can justify with the calculator, and we can make some determinations using some of the features, okay? But here's the problem with using the calculator. It takes time, okay? And some of the conversations that we're going to have are going to help you save time, okay? So if you guys go back to, again, the geometry students from last year, there were some things that you did with graphs of triangles, rectangles, polynomials, and those were, bless you, and those were transformations. The words reflection, the words translation, the words rotation, right? Dilation, right? Those all sound familiar, correct? Okay. So for the geometry students, when I say the word rigid motion is a transformation. In other words, taking something like this. I can do a rigid motion by moving it around the plane. So I could shift it left and right. I could shift it up and down. I could rotate it. I could reflect it. And by doing any of that, did the object itself change size or shape? No, right? The only thing that would change the size or the shape of this is if I was to what? Dilate it, right? Make it bigger or smaller, okay? So we're going to talk about both some rigid motions as well as some dilations, okay? So for the algebra students, those are new phrases, okay? For the geometry students, those sound familiar. So here's what we're going to do. We're going to take this, which is an absolute value, right? And it says without the use of the calculator, what does the absolute value of x look like? Well, the absolute value of x looks like this. It's that V shape. And looks like that, right? So there's your absolute value of x. All right, so I'm going to give you guys the rule right now. Okay, I'm going to give you the rule right now in terms of what's going to happen when we graph these other two. Okay, so the first one I want to graph. Actually, I'll do this one in red. First one on the graph is that, okay? Now it says do this without a calculator, okay? The only way that we're gonna do this without a calculator is probably to create a T-chart. Agreed? All right, so I'm gonna create a quick little T-chart of X and Y. And because I kind of already know what this is gonna look like, I'm gonna tell you what values to use, okay? All right, so I wanna use these values. So we'll do these verbally, okay? Plug in -1. -1 minus 3. -4. What's the absolute value of -4? 4. 4 plus 2. All right, so we have -1, 6. 0 minus 3. Absolute value. Plus 2. 1 minus 3. Absolute value. 2 plus 2. Okay. 2 minus 3. Absolute value. Plus 2. So right now it looks like it's what? Just getting lower, but we know that it's an absolute value graph, so it's going to eventually pop back up, right? Plug in 3. What's 3 minus 3? 0. 0 plus 2. Okay. 4 minus 3 is, say again? 1. 4 minus 3. Right? 1. Absolute value of 1. 1. 1 plus 2. 3. And uh-oh, there it is. It's popping back up now, right? 5 minus 3 is 2. 2 plus 2 is 4. All right, so with a T-chart, right, we get this. So if we plot these points, -1, 6, 0, 5, 1, 4, 2, 3, 3, 2, 4, 3, 5, 4, and it looks like this. So for the geometry students, does that look like it's a rigid motion? Does it look like it's the same shape? In other words, the V, right? The V didn't get like any narrower or any wider, did it? No. Okay, so that's something we'll talk about in a moment, okay? Hezi, what's this point right here? What's this turning point? 3, 2. So the vertex is 3, 2. I want you to take a minute. Caesar, take 2 seconds. And I want you to look at this and look at this and see if you can find a relationship between the vertex and the equation. Okay, don't say it out loud. See if you can come up with one in your head. So this is the equation. That was the vertex. Okay, you got an idea what you think might have happened? Okay. All right, let's do this one and let's see if your idea was right or not, okay? All right, so we're going to do this one. Same exact process. We'll do it over here. All right, Caesar has an idea. And we'll use these values. Again, I kind of know what it's going to do, so I'm picking these values purposely. Okay, -3 plus 1. -2, absolute value. 2 minus 4. -2. -2 plus 1. -1, absolute. Okay, 1 minus 4. -3. 1 minus 4, right? 1 minus 4, -3. -1 plus 1. 0 minus 4. Okay, plug in 0. 0 plus 1 is 1. Absolute value of 1 is 1. 1 minus 4 is -3. And this is going to be -2. And this is going to be -1. And this is going to be 0. Promise you. Not lying. All right, we're going to plot those points now. So I go to -3, -2. -2, -3. -1, -4. Here. Here, 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 and it looks like this. Briggs, what's our vertex of this one? -1, -4. -1, -4. That's our vertex. Caesar, quick question. Based on your analysis, is what you thought was going to happen happened? It did? Okay, good. You want to articulate what you hypothesized over here and how it worked over here? Yeah. So what he said was whatever's inside of here, this number was the opposite, right? So this was x minus 3, this was a positive 3, and then this was plus 2, and this was positive 2. So the one on the outside stayed the same. The one on the inside changed sign. So if I look at this one, the opposite of this is -1. This stayed the same, so the vertex is -1, -4. Yep. You would have a pretty good idea. Yeah, you would have a pretty good idea. So what I want to talk about here, guys, is what's going on. Guys, this was a what? Check it out. Watch this. Watch what I'm going to do. I'm going to take, can I combine these anyway? Oh, I need to have my computer mouse or my keyboard. All right, anyways, let's suppose that these were to, let's see if this will work. Maybe this will work. All right, so here's my blue one, right? My blue one, Caesar, do you agree with my blue one I didn't do anything on? Right? That was just the absolute value of x, right? Oh, I can't combine these. I want to group them. You think I can? See, it won't let me select more than one thing. This thing's stupid. Well, watch, I'm going to do this instead. I'm smarter than your average bear. That was my original one, right? So watch what happened to my original one. I'm going to take my original one and see how it just simply what? Shifted, right? It shifted. It shifted to the right and it shifted up. It shifted to the right, how many units? 3. It shifted up, how many units? 2, right? Okay, so if we go back here, all right, how did I go to the green one? I shifted to the left 1. I shifted down 4, right? So we're seeing that what the title of our lesson, shifting functions, is holding true, isn't it? All right, we're just shifting left and right or up and down, okay? So if I gave you this based on Caesar's hypothesis, right, what would you expect this graph to do? You would expect it to shift to the right 6 units and what? And down 8 units. Shift right 6 units and down 8 units, right? Based on the signs of this. All right. And that's what this says down here, guys. It basically, in really, really complicated terms, says that when you shift left and right, it's the opposite sign. And when you shift up and down, it's the actual sign. Everybody good? All right. So if you were looking at this, right? I tell you, if you were looking at this based on the conversation that we just had, would you agree that this is like the inside of the absolute value and that is like the outside? So if you were looking at this graph and I asked you, how is it going to shift? What would you suggest it might do? Oh. Agreed? To the right 3, up 1. That's going to go to the right 3 and up 1. So what I'm going to do is I'm going to take this, 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 and this. Those are the 4 points that create that function, right? And I'm going to take all 4 of those points and shift them to the right 3 and up 1. And connect the dots. It looks like that. Geometry students, is that a rigid motion? Yes, because it's the exact same size and shape, right? Okay, so in other words, I could move that around and have it land directly on its original spot, right? Without stretching it or shrinking it. So definitely a rigid motion. Using this, oh, by the way, we got to label this, guys. The original one was f of x, and our new one is g of x. All right, so based on what we just did, what is the value of g of 0? What is the value of g of 0? Well, g of 0 is what happens when I plug 0 into the function, right? So if I look at the green function, where am I? At 0. I'm at 0, 2. I'm at 0, 2. Guys good? Okay. Identify how this how this graph has been transformed to produce the graph and sketch it. So we just did that. It was shifted to the left 3. I'm sorry, to the right 3. Thank you. To the right 3 and up 1. So what do we notice here, guys? We notice that not only will absolute value graphs take on this type of transformation, but so will a random graph like this. Cool? Okay, so this one's kind of weird, guys. This is where you really, I really sort of have fun. I really get to test whether or not this makes sense, okay? Because this is like the next level type question. It says that I have a function, f of x. That function has a domain -3 to 10. So what does that mean? It means that if I was to graph f of x, it would start at -3, it would end at 10. So this is going to be a graph of f of x. And then it has a range where y is less than or equal to 22. All right, so what does that mean? It means that if I was to actually graph it, the whole graph is going to be less than or equal to 22. Sean, do I have any idea what this graph is going to be? No, right? I just know that it has a domain and has a range. But could I create a graph that takes on those attributes? Sure. Let's put a point. Watch this, guys. Let's put a point right there. Is that a point that begins at -3? Okay. How about if I put a point right here? Is that a point that is at 22? Okay. How about if I put a point right here? Is that a graph that ends at 10? All right. And if I connect these dots, isn't that graph? Oh, by the way, hang on. I got to change one thing. Actually, I got to change a lot of things. I lied. Sorry, don't get mad at me. Jeez. Okay, what do you want from me? Yeah, that's right. Nobody is. Here's my problem with this, guys. It says y is less than or equal to 22, right? So is negative infinity part of that? Yeah. So if I was to graph this, I suppose I could probably graph something like that. I can't really go down that far, right? I can't really go down there without. Yeah, you see what I'm saying? I can't really get down to a negative value and hit all these points. So that's our issue. But nonetheless, let's just see if we can figure out what the problem's asking us. It says, what is the range of another function if I do this? And what is the domain if I do this? So guys, talk to me about what I'm doing to this function. I'm shifting it to the left 7, and I'm shifting what? Up 10. Okay, so guys, if I shift to the left 7, this point is going to go to where? If I shift it to the left 7, where's it going? To oh no, but where is it right? Yeah, it's a -3 right now, right? So if I shift it to the left 7, it's going to go out to -10, correct? Guys, if I shift this point to the left 7, that was a y value of 22, right? So does that change? No. This point was at 10, right? So if I shift it to the left 7, where's it going to go? It's going to go to 3. So what's going to happen to the domain? The domain, which was -3 to 10, is going to change to be -10 to 3. Trinity? Because it's always the opposite. It's always the opposite. Okay, so that's the next part. The next part of it is this part, right? This moves it up 10. Is it going to change the left and the right? Right? It's not going to change it, right? If I move this, I can't do that. Jeez Louise. Let me do it this way. Sean, there's this, right? If I take this graph and move it up 10, it doesn't change left and the right, does it? The only thing that changed left and the right was the fact that I had to shift it to the left 7. So there's my left 7, right? And then I go up 10. So the only thing that changes is the fact that the highest point is no longer 22. What's the highest point now? 32. So I know that for my range, I need y values that are less than or equal to 32. Because I did what? I shifted my graph up 10 units. Cool? All right, so last bit. And this, we're going to actually fly through this pretty quickly. Here I give you a quadratic, right? Guys, I'm going to give you a new phrase. It's called a parent function. Circle that. If you see this, based on our conversation and last unit, the only thing that's being squared here is the x, right? If the x is being squared, what kind of a graph am I going to get? A parabola, right? So I know that if I didn't shift this around, I would just have y equals x squared. So that's called a parent function. Now, do we all agree that if I created a t-chart for this, right? If I created a t-chart for my parent function, I would have this. I would have x and y. I'm picking these values just because I want to. So I'm just going to graph my parent function quickly, okay? Guys, what's negative 2 squared? 4. What's negative 1 squared? What's 0 squared? What's 1 squared? What's 2 squared? So if I plot these 5 points, I'm going to get a picture of a parabola. Negative 2, 4. Negative 1, 1. 0, 0, 1, 1, and 2, 4. So this is going to be a picture of my parabola. Bless you. Guys, that is the parent function, right? Bless you. That is the parent function. Now, Trinity's got it cleared up. If I look at this, what would you suggest is happening? This is being shifted to the left or right? To the right 4 and down 5. So this is going to shift to the right 4 and down 5. So what's going to happen to my turning point? My turning point, which was 0, 0, is going to become 0 plus 4 and 0 minus 5, right? Because I'm shifting it to the right 4 and down 5. So what does it become? It becomes 4, negative 5, doesn't it? So my new turning point is going to be here, 4, 4, negative 5. There's my new turning point. Now, guys, what else is going to move? All the other points, right? How are all the other points going to move? The same way. They're going to move to the right 4 and down 5. And that's the transformation of all those points to the right 4 and down 5. So I just took each individual point and moved them around. Connect the dots. And that is my new function of x minus 4 squared minus 5. All right, so we sketched f of x, right? Here, if I was to ride this like a roller coaster, I'd get on and I'm going down a hill, right? If I'm reading this left to right, and then I get to the bottom of the hill and then I start to what? Increase. So where is this graph increasing? It starts increasing here and it continues to increase for how long? Forever, right? Yeah, so at what x value does it start increasing? 4. Yeah, it starts increasing at 4, and then it's increasing at 5, and it's increasing at 6, and it's increasing at 7, and it just keeps increasing, right? So the interval starts at 4 and goes to infinity with a parenthesis, because am I increasing at the bottom? No. Or where x is greater than 4, right? So it's where x is greater than 4. All right, last question of the day. Oh, no, it's not. I lied. Which has a lower minimum value? The function f, which I just drew, right? So what was the vertex of f? It was 4, -5, right? So now listen carefully. What's the minimum value of the blue graph? What is the minimum value? If I say the minimum value, I'm looking for the, I'm looking for the lowest. Yeah, I'm looking for this low value right here. So it's at -5. So when I ask for a minimum, I'm looking for a y value. Right? Minimums, maximums always are referring to highest and lowest. All right, so now if I was to graph this, this would be an absolute value graph with a vertex at 6, -10. So what's the minimum value of this one? -10. So which one has a lower value? This one. All right, last bit. This is a graph of f of x. It said so in the directions. Hey, notice something. Are there arrows at the end of that graph? No. So does it go on forever? No. Okay. It says show that -1 and -2 are zeros of the function g. Is this the function g? No, this is the function what? F. So what do I need to do to create g? Take this graph and shift it to the right 2 units. Do I shift it up or down? No. So this is just going to shift to the right 2. And what points am I going to move? Well, guys, this is actually kind of important because I have this value where it begins. I have this value where it has a maximum. I have this value where it ends, but it's asking me about roots. So I also have some roots that are going to move around, right? So let's move these and see if we can do anything else. So I'm just going to take these 3 values and do what? Move them to the right 2 units. Connect the dots. And there it is. And what are the roots? Show that -1 and -2 are zeros. Okay, well, we did that. Last question, for real this time. Evaluate each of the following. So this blue one is my function g of x, right? So what is the value of g of -3? So -3 puts me right here at that minimum value, right? That's -3, -1, 2, 3, 4, 5, 6, -3, -6. And at 0, I'm at 3. And at 4, I'm at -3. Shifting functions, rather easy, isn't it? Okay, whatever's inside of there, we're going to do the opposite. Whatever's on the outside, we're going to do the actual.